Alright, hello viewers. Now in this video, I want to resolve this expression right here, alright, into partial fractions. So you see that in the numerator, we're having x squared, and in the denominator, we're also having x squared, that is the highest power, okay, in the highest degree in the top and the bottom. You see that they are the same. So this kind of fraction is called an improper fraction because the degree in the top is the same thing as the degree in the denominator. Okay, great. So to actually resolve this to partial fraction, we need to first of all make it a proper fraction. Then thereby we go ahead and see if we can resolve the other part. Now this is what we will do. Okay, so let's say first of all put that down. We have x squared over x squared plus x minus 2. Okay? Now, I can rewrite this in a way that I have something very nice. Now I'm going to do addition by 0. Now this is what I mean. You know, if you add 0 to something, it does not change it, right? Okay, great. So what I would like to do is to rewrite the numerator to be the same thing as the denominator. So here I'm going to rewrite this as, take a look, we have x squared, then this is plus x. So I'm going to go ahead and use something here, plus x, alright? And then this is negative 2. So I subtract 2 from it. Now we have the denominator to be x squared plus x minus 2. Now you see the numerator was just x squared. Now I've added x to it and I've subtracted 2. You see that the top and the bottom are the same in this case. Alright, so we can just cancel them. But you notice that we've changed everything in the numerator, so we need to balance it. And by balancing it, we need to subtract this x again from it. So we subtract the x and we add 2. So what we've just done here is addition by 0. We said x minus x will be 0, and then negative 2 plus 2 will still be 0, and we get back the x squared. So what I did here was a kind of manipulation so that I will be able to get something like this. So this is the same thing as that. So I can rewrite this as x squared plus x, okay, the top now, minus 2, alright? Maybe let me just interchange this and that. That will be plus 2 minus x. That is the top, alright? Divided by x squared plus x minus 2. So you notice that at the top, if you compute everything again, you are going to get back just x squared. All this will be 0 because this is just an addition. And this is the negative of it. This is the negative 2, and this is the positive of it. If you add them together, they will be 0. Okay. Okay, so from here, we can go ahead and split these fractions. So you notice that this, right, I'm going to split them and keep a common denominator. So this will mean that we are going to have x squared plus x minus 2, right, divided by, that will be my first fraction, okay, x squared plus x minus 2. Then I add it with, we now deal with this addition. Then we have 2 minus x at the top. Then we still keep down the same denominator, alright? We put down x squared plus x minus 2. So you observe here that if we add these fractions backwardly, okay, if you add these fractions together, the denominators are the same. So you take one of it, that is, you keep it common. And then you add the numerators, which will get us back to this. Alright? Notice that the negative 2 and 2 will be 0, and x minus x will be 0, and we are just having x squared. So it's the same thing. Okay, so you notice that here we are having this and this, they are the same. So if you have the top and the bottom to be the same, the result of the fraction will give you 1. Alright? So in fact, everything here gives us 1. So I just put it down as 1. So we have 1 plus the whole of this. Alright? Okay. So this is a representation of that stuff there. Now, what I just did here was, let me equate them so that we see this is the 1. We have here to be x squared over x squared plus x minus 2. This is equal to that. Okay, so if you observe, what I just did here was that we had an improper fraction. Now, I have reduced it, okay, into a mixed fraction. Here is the 1. And here we are having a proper fraction where the degree at the top is less than the degree at the bottom. That is a proper fraction. So we just did a reduction, all right? Okay, great. Now we still need to resolve this to partial fractions. So what I will do here To resolve this completely into partial fractions, we still need to resolve this one because this is factorable in the bottom, all right? And from there we can get some other smaller fractions of this one. Okay, so what I would do is to get the smaller fractions of this one, then I substitute it here and we equate it to the left hand side. So I will solve this one over here. So let me use blue for that. So we have here 2 minus x over, now see this denominator, x squared plus x plus minus 2. This denominator has some factors. Well, we can use the factorization method here, but to actually get the factors of this, we will need to think of two numbers whose product will give you this last term here, -2, okay? And whose sum will give you the coefficient of x. So those two numbers should be such that whose product will give you now -2, in this case, that is -2 times 1, and whose sum will give us +1. Well, after everything, we are going to have that x minus 1 and then x plus 2 are the two factors, because the two numbers we can multiply are -1 and +2. The product will give us -2, but -1 plus 2 will give us +1. And here is just 1. Okay, so this is what we'll substitute in place of this, right? So these are the factors of that. So we'll have, at the bottom we'll now have x minus 1 and then x plus 2. So this is the same thing as this one. So maybe here, I just rewrite this as that. X minus 1 and then x plus 2. Okay, great. Now here we need to resolve this to partial fractions, and good enough, the factors of this in this denominator, okay, the factors, they are all linear factors. So by resolving to partial fractions, when we have linear factors in the denominator, we have a very simple pattern for it. This is how we write it as. We say this is equal to, we will put down the factors itself. The first factor here is x minus 1. So we put it down, x minus 1. Alright? Now we are going to split them. Okay, so this is actually the denominator. Now we are not going to multiply them again. We are actually going to put them as denominators of two different fractions. We put the next factor, x plus 2. Okay, maybe there is no point for this for now. Alright. Now, this is actually a fraction, okay? I have not written something at the top yet. So I'm going to write something, but I want to explain. So we have this and that over there. Now, when we have linear factors like this, how do we go ahead and split them or resolve it to partial fraction? Well, you put down the linear factors. Since this is linear, alright, the numerator should be a constant term. That is a term whose power is 1 less than the denominator. The degree of the numerator should be 1 less than the degree of the denominator. So if here is power 2, here should be to power 1, right? So we are going to write a linear polynomial over there. But since this is just to power 1, here we are going to have to power 0, which is just a constant polynomial, and we are going to put it down as just a, and we denote it with a capital letter. Let me put this over here, right? Okay, so the next thing is applicable to the other fraction. Since the denominator is just a linear factor, so the numerator will be a 1 degree less than that linear, which is just a constant term. So this is, let's follow the alphabetical order. The next one is going to be b. Okay, so notice that if we had a quadratic at the bottom, then the top will be a linear function. For example, bx plus c, right? Bx plus c, that is a linear something. Okay, so we need to go ahead and solve for this. Well, to actually solve for this, there is a simple method I'm going to use here. Alright, I'm going to use the Coveral method. So we have to solve for this constant a and b because they are the unknown right now. When we get their values, we just substitute it, and this has been decomposed into its partial fractions. So we need to solve for this value of a and that of b. So to solve for a, we need to look at the denominator. Which value can we put for x, which is a variable in this case? Which value can we put for x such that the denominator of a will be 0? The answer is 1. You know, if x is equal to 1, this will be 0. So you come over to this left-hand side. When you see x on this left-hand side, you plug in 1, right? That value that will make this to be undefined. So that will mean here we come to the left hand side, we are going to have 2 at the top minus x. So 2 minus 1 in this case, that will be 1. Then at the bottom, we cover this up. This is where the coverall method comes in. You get this factor. To solve for x, you substitute a value that will make this to be 0. When you get that value, come to the left-hand side, cover up that particular factor, alright? So we come and cover up this x minus 1. We substitute 1 for x at the top, we have 2 minus 1, which is 1. We substitute 1 for x at the bottom, we have 3, right? Okay. So we also do the same thing for b. So to solve for b, we will need to look which value of x will make this denominator to be 0. So all you need to do is equate x plus 2 to 0. X will be equal to negative 2. So come over here, cover this factor up, substitute that negative 2 into the other expressions, alright? And into this other factor for x. So you substitute negative 2 for x, we are going to have, maybe let me put this down, this is for a. So we are going to have for b, so that will be negative 2. So at the top we are going to have 2 minus negative 2. In place of x we just put negative 2. That should become 2 plus 2, which is just 4, alright? Then at the bottom, we are going to cover this up. Then negative 2 minus 1, that is negative 3. So this is negative 3. It's the same thing as putting it there. So that is the value of b. Okay, so we've successfully solved for the value of a and b. So that means that in place of a here, I can just put 1 over 3. And in place of b, I can put negative 4 over 3. So in place of a, I would like to put 1 over 3, and in place of b, I will just put down negative 4 over 3. So that is it for this other fraction. So we need to replace this, right, with that in this place, because they are the same. Okay, but I can write that thing in a very nice form. Let's see. Well, here, let's just replace it over here. We'll come back here and rewrite this as, okay, put down the main thing, minus 2. This is equal to 1 plus, so the whole of this is what we have over there, which is 1 over 3. Divided by x minus 1, it is the same thing as 1 over 3 times x minus 1. So you see, we are having division of fractions. So this 3, which is the denominator of the numerator, okay, it will come down to the denominator. Then that 3, which is in the denominator of the numerator, it will come down to the numerator after simplifications. So we will have negative 4 over 3 times x plus 2. Okay, so this is the decomposition of this right here. Okay, thanks for watching, and please subscribe to my channel.